Okay, let's take a look at section 5.6. We're going to be proving triangle congruence by ASA and AAS. So let's start right here on this page. This is page 28 out of your student journal. And in this table, it says, let's take a look at these possible congruence theorems and determine whether they are valid or not. So hopefully the first one right here we know as side, side, side. That is a triangle congruence theorem that we first learned. Okay, so this one right here will be yes, or the one that we just learned in 5.5. So that one works out. Super. Okay. Next up, we have SSA, which is side, side angle. Now, we haven't learned anything about SSA. Or if we turn these letters around, it's also right here, angle, side, side. And so here's what I want you to remember. We never learned SSA or ASS, and we are never going to learn that because this is not valid. So never use angle, side, side, or I'll think that you might be an angle, side, side because you're not paying attention, or side, side angle. So hopefully you can remember that that is not valid. The first one we learned, coming up next, side angle side, that is a valid triangle congruence theorem. And then we have angle, angle side, AAS. Well, that's what today's lesson is about. So hopefully that tells you that that is valid and it makes sense. We've got ourselves angle side angle. That is also another thing that we're learning today. That is yes. And then we have AAA. Well, AAA. Well, maybe if you need to find a roadmap or you need to change your tire, that'll be a valid congruence theorem. But right here, not valid. All right. Now think about it this way. If I have two triangles that are congruent, or two triangles right here, we'll say this equiangular. Now I've got this bigger triangle right here. It could also be equiangular. But are they both equilateral? There's nothing that proves that. Okay, so therefore, I cannot use angle, angle, angle to say that we have triangles that are congruent. All right, so let's go ahead and move on to today's lesson. So we know right here that angle side angle is one of our congruence theorems. And so let's go ahead and read this. It says if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So remember, it has to be an angle, the included side, and another angle for us to use ASA. You can see that once again right here. Angle, included side, and an angle. Included side, what does that mean? It's in between the two angles that we're going to use for the theorem. Just like how we have side, angle, side. And in side, angle, side, we have the side, the included angle, and then the side. So those are the parts that we're going to need to prove congruent in order to use angle, side, angle. We take a look next up at Theorem 5.11. We have angle, angle, side. So in this one, it says if two angles and a non-included side. So before, it was always like, we have our triangle, we have angle right here, angle right there, and then this was the side where my thumbs are. Well, this time, we have angle, angle, and then we have a side that's not in between. So maybe the diagram can show that too. Right here we have angle A, angle C, and then we have the non-included side. Congruent to angle D, angle F, and EF is that non-included side. So that's how we can use angle, angle, side congruence. So let's take a look right here at number 1 in the extra practice. It says to decide whether enough information is given to prove that the triangles are congruent. If so, we state the theorem that you would use. Okay, so we're trying to prove that triangle GHK and triangle JKH are congruent to one another. Now, don't forget, it's always important, just because you see two figures and you see sides that look like they're congruent or are congruent, remember, they have to correspond with the sides and angles of both triangles. So if I look at angle G, it needs to be congruent with angle J. So let's see. I look at G and J, those two are congruent. Okay, we have angle H, that's supposed to be congruent to angle K. Let's look on the diagram. We have H and K congruent. Excellent. And then we have GH. So GH is the first two letters of each of the triangle, and JK is the second two letters. And guess what? They are congruent. So one of our congruence theorems is angle, angle, side. Angle, angle, non-included side. Angle, angle, non-included side right there. And we can go ahead and say that triangle GHK is congruent to triangle JKH. Let's go next up to number 2. We have triangle ABC is see if it's congruent to triangle DEC. So let's see, we have angle B and angle E. Hey, those are congruent. They may not be in the same side, right? This is on the left, angle E is on the right side of this triangle, but it's okay because they are both congruent according to the order in which the triangles are, the statement is written. Angle C and angle C right here, well, they're both congruent in each, makes sense. And then we have BC and EC are congruent, and yes, they are. So this one, we have angle, side, angle to prove that these two triangles, ABC and DEC, are congruent. Let's take a look next up at number 3. We've got triangle JKL. So let me see right here. JKL. So let me highlight that right here in blue. And we're trying to see if it is congruent to triangle MLK. And K. All right, so let's see what I have here. I know that angle J is congruent to angle M. Great. JN is congruent to J or NK. Or let's say JL is congruent to MK. Okay? Looks like it matches up according to our statement here. Now, we have to have another angle that's congruent in order for us to use angle, side, angle. I know nothing of angle L or JLK. I know nothing of angle MKL. So I can't say that they are congruent. I can say that both triangles have KL right here congruent, though. Don't they both share that? So let's take a look. Angle, side, side. That's a no-no. Or side, side, angle. That's a no-no. These two triangles are not congruent. We cannot prove that. Okay, lastly, let's take a look at number 4. We've got right here, let's see, RS should be congruent to UV. Looks good on the triangle. right? They both have congruence. We've got ourselves W, angle W should be congruent to angle T according to our statement. Good, they're both 90 degrees, so I know that that is true. And then finally, let's see, angle S right here should be congruent to angle V. I look at angle S and angle V. So what can we say? If you said angle, angle, side, that is correct. Okay, we have angle, angle, non-included side right there. And it is now, we could prove that they are congruent. All right, next up, looking at number 5, it says decide whether you can use the given information to prove that triangle LMN is congruent to triangle PQR. Easiest way to do this, draw out 2 triangles. Guess what? I already have 2 right there. Works like magic. Let me go ahead and label this LMN, and that's supposed to be congruent to P, Q, and R. All right, so let's see what information they give us here. They give us angle M, angle Q is congruent, angle N is congruent to angle R, and then it says NL, which is right here, is congruent to RP. Looks like we can use right here, we could say that they are congruent, and that is angle, angle, non-included side. We're going to go ahead and put angle, angle, side right there for number 5. Okay. Let me go ahead and erase some of the markings that we have so we can do number 6. So in number 6, it says that angle L is congruent to angle R. Okay. Angle M right here is congruent to angle Q. And then we have LM is congruent to PQ. All right. Well, I see right here we got angle, side, angle. I've got over here on this side, I've got angle, angle, side. Those 2 triangles, I can't prove they're congruent because they have 2 different ways of showing that. 2 different theorems. Also, another direct giveaway. So this one right here, we can go ahead and say is no. But one thing that stood out to me right here is this. We've got angle L is congruent to angle R. Okay. Take a look at our statement up at the top. L is the first letter, R is the last one. Just by looking at that, that's something that sticks out and should be pretty fishy to you. And therefore, that doesn't work, and we go ahead and put no right there. Okay. All right. The order of these statements are important. If L starts off first, then R needs to start off first right here in the statement, and it doesn't. So that's where I already knew. I said, hey, there's something wrong here or something fishy, and we just sniffed that out. Okay. Let's go next to number 7. We're going to do some proofs here. So it says we're going to prove the triangles are congruent using angle, side, angle, congruence theorem. We have to start off with AC bisects angle DAB. So let's see if angle A or ray or segment AC bisects DAB. Okay. Then remember, if it bisects, I should know something about the angles. These 2 angles right here should be congruent. You don't say. Well, maybe you're going to have to use that right there for in our proof. Next up, we got angle DCB. It says this segment is also bisecting this bottom angle. So remember, we're going to have two congruent angles right here. And let's go ahead and show that in our diagram. Let's start putting everything together. Statement 1, hopefully you realize, hey, that's supposed to be the given. So we have AC bisects angle DAB and angle DCB. That's given. Let's go ahead and put right here, statement 2. Well, if I look, I've got two angles, and we have angle, angle, side. But we're supposed to prove using angle, side, angle. So it's like almost choose your own adventure type of deal. There are the, figure out, well, how can we solve this out based on the given information? Well, they already tell us how we're going to prove this, which theorem we're going to use. So if I am a gambling man, I'll say that this is the angle, this is the angle, and right here we have our included side. So let's go ahead and put that down. For this second statement, I could say AC is congruent to AC. We have our reflexive property. Okay, so we got ourselves a reflexive property right there for number 2. What else can I include? Well, in statement 3, remember, we have to prove angle, side, angle. So I've got to figure out, well, what angles are congruent with each other. That's what we're going to put next. So I'm going to go ahead and take a look at our diagram and realize, okay, we've got ourselves angle, how about BAC, this one up here, that's congruent to angle DAC. Why? Well, what did that segment do? It bisected the angle. So let's go ahead and right here and put definition of a angle bisector. And there we have number 3. I think we have another angle that got bisected, right? This one right here. So let's go ahead. We'll add this onto statement 3, and I could say that angle BCA is congruent to angle DCA. Definition of angle bisector. So we put everything together. I've got angle, once again, included side, and an angle. And I can go ahead and finish this and state that triangle ABC is congruent to triangle ADC. And why? Because we have angle, side, angle as our answer, or as our reason. I love it when a plan comes together. All right, let's go next up. Last one, number 8. We're going to prove that the triangles are congruent using angle, angle, side. Starts off right here. They say that O is the center of the circle and angle N is congruent to angle P. So let's go ahead right here. I'll put that down. Center of the circle and angle N is congruent to angle P. And so that right there is given. There's some real important reason why they told us that O is the center. Because then you should be able to look and determine something about the sides. That'll help us with statement 2. O to N. What type of a segment is that? If it's from the center to the outer part of the circle, that's the radius. ON is a radius. OQ is a radius. OM is a radius. OP is a radius. It's like Oprah, right? We're handing out, you get a radius, you get a radius, you get a radius, right? Not really. But hey, we have multiple radius. We don't say radiuses, we say radii. So now let's go ahead. I'll say ON. Okay? That segment is congruent to OQ. Congruent to OP. Congruent to OM. Reason, let's go ahead and put right here that all points of a circle all points on a circle are the same distance from the center. Maybe we could use definition of a radii or definition of a radius, because that's what they are. They're all, but I guess if we want to be a little more detailed to the person that's reading the reason, we could say that these segments, they're all equidistant because from the center to the outer part of the circle. All right, so we've got that down. What else can we use here? Angle, angle, side. If I use angle NOM, that doesn't really work out because angle, side, angle. So let's look at the diagram carefully. Look at one of the triangles. What do we know about the triangle right here? If I have two sides that are, two legs that are equal, then we have ourselves an isosceles triangle. See how we put it all together. And in an isosceles triangle right here, check this out. Remember, the sides and the angles, they dictate how big the sides are. Well, if these two sides or legs are congruent, then these two angles right here need to be congruent as well. The same thing applies to this triangle on the right side. It's amazing. Why? Well, I'll let you think about that as I go ahead and write the statement. Because now angle N is congruent to angle M. Angle M is congruent to angle P. And angle P is congruent to angle Q. All of these angles are congruent to one another. Well, what is the reason for that? These happen to be base angles. So let's say the base angle theorem is the reason why they are all congruent. So let's hopefully now I've got angle, angle, non-included side. Or I can go the other way, angle, angle, non-included side, and same with the triangle to the right. So knowing that, I can go ahead and say that triangle M and O is congruent to triangle PQO. And that is your angle, angle, side congruence theorem. All right. So there you have it. You now know how to solve or prove triangles are congruent by ASA and AAS. Okay. Remember, don't ever use angle, side, side.